Assalamualaikum. Welcome again to mathematics, and now we are going to do question number 7, and that is about the trigonometric identity. So the question says that prove this identity: tan theta plus 7 over tan square theta minus 3 identity sine theta cos theta plus 7 cos square theta over 1 minus cos square theta. So first we have to do this. Now let's start solving this. So we will be taking left hand side. We are taking tan theta plus 7 over tan square theta minus 3. And we always know that wherever we have tan theta in trigonometric identity to prove, we will be substituting that equals to sine theta over cos theta to get the required form. Okay. So sine theta over cos theta plus 7 divided by sine square theta over cos square theta minus 3. Now taking cos theta as a common denominator in the numerator and cos square theta as a common denominator in the denominator. Okay, so let's take that. First take this. And now sine theta plus 7 cos theta over cos theta, and in the denominator sine square theta plus minus 3 cos square theta over cos square theta. So this will give you cos theta and cos theta, it cancels, so we are left with sine theta plus 7 cos theta, and this cos theta will be multiplied with the numerator when this is multiplied as a reciprocal. So we are left with sine theta plus 7 cos theta over times cos theta divided by sine square theta minus 3 cos square theta. Now look for which form do we need. We need a denominator independent of sine, and the numerator, I guess, only need simplification to get the required form. So do that. Sine theta cos theta when multiplied with this outward cos theta, outside cos theta, and then the 7 cos square theta. This is already simplified. The next thing that we should be doing is changing the sine square theta into cos square theta. So the next thing that is used in trigonometric identity is using any form of this formula sine square theta plus cos square theta equals to 1. And just let me rewrite sine square theta plus cos square theta equals 1. So we always use these two to simplify our trigonometric identity. And from here we get to know that sine square theta will be equals to 1 minus cos square theta. So substituting that, 1 minus cos square theta minus 3 cos square theta will give you sine theta cos theta plus 7 cos square theta divided by 1 minus cos square theta and minus 4 cos square theta. So this will give you 1 minus 4 cos square theta. So this is how you prove the identity. Now we have to do part B of it. Part B is this. Hence solve this equation. So solving this equation means, as we have already proved that this is equals to this side. So now they are giving you the right hand side to be equals to 5 tan theta. So what we can do, we can equate this tan theta over tan square theta thing equals to this because they both are identical. Okay, so let's do that. So we have tan theta plus 7 over tan square theta minus 3. To be equals to 5 over tan theta. Now we have to solve this. Okay, so solving this all. To solve this, first what we have to do, we have to cross multiply. So tan theta times tan theta plus 7 equals 5 times tan square theta minus 3. Tan square theta plus 7 tan theta equals 5 tan square theta minus 15. Now arrange this, shifting this tan square to the other side. It will become 5 minus 1, so it will become 4 tan square theta. Minus, this was also going on the other side, gives you minus 7 tan theta. Minus 15 equals 0. Now, this is your quadratic equation in tan. So what you can do is either substitute tan theta equals to some other variable a and then solve the quadratic equation and then substitute this back. But I am solving this in directly in tan theta. Okay, I'm taking the variable to be tan theta. Okay, how do we solve this quadratic equation? By breaking the middle term. We need 15 times 4 is 60. So we need two numbers which when multiplied gives you minus 60 and when added up gives you minus 7. And that is 12 and 5. So minus 12 tan theta plus 5 tan theta plus 5 tan theta minus 15 equals 0. And this is going to be again the same 4 times theta. Now taking 4 tan theta common. So it will give you tan theta minus 3 plus 5 common tan theta minus 3. Taking tan theta minus 3 common. And we are left with 4 tan theta plus 5 equals 0. So this implies either tan theta minus 3 equals 0 or 4 tan theta plus 5 equals 0. So tan theta equals 3, which is not possible because tan inverse of 3 is not possible. It is greater than 1. So no solutions for this. Or you can write not possible. And the other one would be tan theta equals minus 5 over 4. Theta equals tan inverse of, okay, so first finding the basic angle. instead of finding the theta, ignoring this negative sign, and alpha will be equals to tan inverse of 5 over 4. Okay. Our range is given to be in degrees, so we'll find the angle in degrees. Tan inverse of 5 over 4 is 51.3401 degrees. Okay. What do we need actually is tan of negative. Okay, where your tangent is negative in the grid, and the range is given to be from 0 to 180 degrees. So just first two quadrants. So where tan is negative in among first two quadrants, in the second quadrant. Okay, so this is A and all positive, and this is sine quadrant. So your angle must be in the second quadrant. Okay, and your angle will turn out to be this from the positive x-axis. So this will be, what it would be, this angle is 51, this is your alpha. So this angle from the positive x-axis would be 180 minus alpha. So your angle theta that you need to find is actually 180 degrees minus 51.3401 degrees, and that gives you 128.6598. You can write up to 2 decimal places, but on a safer side, it's better to write up to 4 decimal places. Okay, so this is your final angle theta. This is how you solve this. Okay, this is your question number 7, part B. And this is your question 7, part A. I hope you understand this. Thank you.